Today we will learn how to use the properties of logarithms to expand and condense logarithmic expressions such as these. So we'll be expanding these, stretching them out, and we'll be condensing these, turning them into a single log, using these three properties. Problem number one, natural log. That's what that is, base E, if anybody cares. That's x over 3y. First thing that jumps into my mind is the quotient property. The log of a over c, that should equal the separate log if we subtract. All right, the difference of the log. So this will become the natural log of x minus the natural log of 3y. Now we can expand this further because of this part right here. There's still a product, the 3y, there's still a product in there. So I will bring down my natural log of x minus. Now you must be very careful on this part. Because there's a minus in front of here, if I expand this into a sum, which I'm about to do, this minus has to apply to both parts of the sum. So I really need parentheses around it suddenly. So I will do natural log of 3 plus natural log of y. Okay, I'm using the product property now. The log of a product equals the sum of the two logs. So that's what we had here. The log of this product, 3 times y, should equal the sum. But again, if you have a subtraction in front and you expand into two things, you have to use parentheses to make sure that the negative sign applies to both things as it should. But then don't leave the parentheses. Then you must go on and distribute the minus sign sort of like this. Think of it as multiplying everything by -1. So in the end, you're going to have natural log of x minus natural log of 3 minus natural log of y. That, my friends, will be your final answer. All right, that part's a little bit tricky. A lot of students will leave off the parentheses and leave this positive, but that's wrong. Okay, taking a look at number 2. This is a clear case of the product property. Log of a product equals the sum of the logs. So that's what we'll do. So we could rewrite this as log base 6 of 3 plus the log base 6 of x. And look, there's really nothing else we can do with that, so that's done. Number 3. I'm definitely seeing the quotient property here. All right? The log of a quotient is equal to the difference of the logs. So we're going to do that. So this will equal the log of 10 minus the log of the square root of x. Now there's two things here. The first trick that you have to watch out for is I'm noticing that we're doing the log of 10, but then please remember there's the invisible base here because this is the common log. This invisible base is base 10. So you should be able to evaluate this in your mind. 10 to the what power gives you 10? That's 1. So immediately you want to go ahead and replace this. Log base 10 of 10 is 1. So let's go ahead and do that. Also, when you have a square root, go ahead and write that as an exponent so that we can go ahead and use the exponent property to expand it further. So the square root of x is the same thing as x to the 1/2 power. And we will now use the exponent rule to bring that exponent to the front. Okay, so I'm doing this, and I will have 1 minus 1/2 log x. And that will be the final expanded answer. Okay, number 4. Okay, I see we've got some product going on, some quotient division, but we need to start with the quotient property. All right, the log of the quotient, meaning division, is the same thing as the difference of these two logs. So let's use the quotient property. All right, so at first we will have this log base 4 of 2xy minus log base 4 of z. So I've used the quotient property. But we must continue because we have a product right here. So we can use the product property to expand this further. Of course, the log of a product is the sum of the logs. So as we expand this, let me just change colors. All right, so notice that there's 3 of them. I can do all 3 right now like this. Log base 4 of 2 plus log base 4 of x plus log base 4 of y. All right? That all comes from this first log. And then I'm going to bring down my log base 4 of z. Now, one of these we can evaluate and get an actual number, and it's this one. See, because we have both numbers and there's a relationship here. So, because the square root of 4 is 2, then as we ask ourselves the question, 4 to the what power equals 2, the answer to that is 1/2. 1/2 power is the same thing as the square root. So this whole thing right here really has a value of 1/2. So this becomes 1/2 plus log 4x plus log base 4 of y. Let me keep with the blue on that one, so everybody can follow where the stuff is coming from. So minus log base 4 of z. And this would be the full correct answer for number 4. Okay, number 5. All right, let's use our quotient rule right away. And so log base 2 of x squared y minus log base 2 of z. Okay, now of course this one can be expanded further using the product rule. So this would become log base 2 of x squared plus log base 2 of y. Okay, and then we still have our minus log base 2 of z. One more thing to do. This exponent, we can use our exponent property and put that exponent out front. So we should and must do that. Okay, so if I take this and put it out front, then we will have 2 log base 2 of x plus log base 2 of y minus log base 2 of z. And that is the end of the line for this problem. Okay, number 6. I see we got a quotient here, so let's go ahead and dive in with the quotient rule. All right, the log of a quotient should equal the difference of the logs, so this will be the same thing as natural log 3y minus natural log of the fourth root of x. It's fourth root. Okay, so there's a couple of different things we can do. This part can expand further using the product property. So this will expand as the natural log of 3 plus the natural log of y, okay, using the product property. And meanwhile, this part over here, just understand that the fourth root is the same thing as x to the 1/4 power. And like we discussed, using the exponent property in expanded form, that power has to come out front. So we will have natural log of 3 plus natural log of y minus 1/4 natural log of x. This would be the fully expanded form for number 6. Okay. Now we're switching to the other mode. We're condensing. So we're going to do the opposite, working backwards. We're given these log expressions that are in expanded form, and we're going to pack them all back in, and when we're finished, we should have a single log instead of log, log, log. Okay. First of all, let's reverse the exponent property. All right, if this c is here in front, it can go back and become an exponent again. All right, so we will take this exponent and put it there. So that means this is going to become log base 5 of x to the 1/2 power plus log base 5 of 3. And in condensed form, we won't leave this as an exponent. We'll go ahead and make this back to square root again. So this will be log base 5 of the square root of x plus log base 5 of 3. Now, so we've got this sum. So we can reverse the product property. All right, if we have a sum of two logs, we can write that as the log of the product. So this would become, as we put these together, the log base 5 of, and multiplying these two together, traditionally we put the 3 in the front. So this will become 3 radical x. All right, so 1 log instead of 2. And so that's what you have for number 7. Okay, number 8. Always reverse the exponent property first. So all of these coefficients that are in the front, they will all become exponents. Okay, so what you hear me saying is this 3 is going to become a power. This 2 is going to become a power, and this 4 is going to become a power. So the first thing I will have is natural log of x to the 3rd minus natural log of y squared minus natural log of z to the 4th power. Okay, now let's go in order. So if I do these two first, all right, just because they come first, the difference of two logs, reversing the quotient property, can be written as this quotient, all right, the log of a over c. So these two will become the natural log of x to the third power over y squared, all right? Notice the natural log, the ln, you only write one of those. So it's the natural log of this divided by that. And just bring this down. So we still have minus natural log z to the fourth power. Now, we have to reverse the quotient rule again, all right? Because still we have this difference, and we're still going to write this as a fraction, a quotient. Okay, and it's got to be this divided by this. Now, let me tell you one extra piece of information before I do this that you may or may not be really familiar with. If I wanted to do, say if I already have a fraction, okay, and my fraction is a over b, and then I suddenly want to divide by another number. So I want to do a over b divided by c, okay, which would be the same thing as having, you know, a over b and then divided by c. Either way you want to look at it, if you divide a fraction by another number, what's going to actually happen is this new thing you're dividing by is just going to become another factor in the denominator. It's going to just join the denominator. Okay? So either way you want to look at it, what you're going to have is a over bc. Okay? So when you divide by an extra number, just put it in the denominator as well. So that's what's about to happen here. I already have a fraction, and what I'm wanting to do is this fraction divided by z to the fourth power. But when you do that, the new thing you're dividing by will just join the denominator. So this will become natural log, whoops, what is that? This will become natural log of x to the third power over y squared, and now dividing by this as well, you just put it in the denominator as well. So this would be the condensed form for number 8. All right, so this might be a new principle for you guys, but get used to it. Number 9. Okay, so the same type of thing. As I put these two together, that's going to be, we're reversing the quotient rule. So a difference will become a quotient, division. So this will be log of 3 over 4 minus log 7. Okay? And as I discussed before, when I do this again, wanting to now divide by 7, that 7 will just appear in the denominator. So this will be log of 3 over 4, and this 7 is going to show up now in the denominator, so it'll be 3 over 4 times 7. Okay, and of course we can go ahead and write that as log of 3 over 28. And that would be the final answer for number 9. Alright, it's starting to get noisy. My first period class will be coming in soon, so I think I'll pause the video here. I'll see you at lunch time. Alright, on number 10, first we've got these two. Well, you know what? Slow down, Burton, slow down. First of all, we've got this coefficient. That's going to come over and become an exponent again if we're going to be condensing. So that would give us log base 3 of 4 plus log base 3 of x squared minus log base 3 of 5. Now, as I put these together, we are going to be using the product property because it's a sum, and a sum of logs can be written as the log of a product. So we will write this sum as the log of a product. So this will condense so far to log of 3, log base 3 of 4x squared. Okay, the log of the product. And I'll just bring this part down. So we have minus log base 3 of 5. So when you have a difference like this, subtraction, then that comes from the quotient property. So I can turn this difference into a quotient, like a fraction. So it's got to be, this has to be the numerator and this has to be the denominator. So this will become log base 3 of 4x squared over 5. And that's all we can do. That's the end. Please make sure you're only writing the word log once. Don't put log 4x squared over log 5. Okay, number 11. Let's see, any coefficients that have to be put as exponents? Yes. This 3, first thing I'm going to do is I'm going to put that as an exponent. So that would make natural log of 56 plus natural log of 1/2 to the 3rd power plus natural log y. And we should go ahead and do this. So I've got natural log 56 plus natural log, all right, 1 to the 3rd power is 1, and 2 to the 3rd power is 8. So this is just going to be 1/8. So that's better. Plus natural log of y. So now let's start combining things together. Now this is all addition. So really I can put these together in one shot, but just understand that addition, a sum of logs, if you condense it, will become multiplication, a product. So it still works even if you have 3 things. Like looking at this property right here, say if I expanded this and said plus log base b of d, then this would become log base b of acd. Okay, you can do a triple, and that's what we have here. So this is going to be the same thing as the natural log of 56 times 1/8 times y. Okay, now 56 times 1/8, right? Remembering that this is like 56 over 1, then 56 times 1 is 56, 1 times 8 is 8. So putting these together, you have 56 over 8 y. Now that's important because obviously this will reduce. 8 goes into 56 evenly. Alright, so this will make natural log of 7y. And that is your final answer. Alright, number 12. Watch very carefully. Number 12 is very special because it has this 1 right here. What do you do with that? The key is we need to make this into a log expression. So we need some sort of a log that would give us 1 as the answer. So you know how those problems work. So, like, would it be log of 1? Would that be it? Or would it be log of 0? Or what? I'm not sure. Well, this will help you remember. Remember that when we have these logs right here, they have an understood base of 10. Okay, so I'm just going to temporarily draw that in. So what I have, so this 1 right here is going to have to come from a log base 10, just like the rest of these. So I need a number that would, if I raise 10 to the 1 power, that should be this other number. And so 10 to the 1 power is 10. Okay, so log base 10 of 10, that's 1 right there, because they're the same. So that's what I need. Now, of course, we don't really write the base 10, so when I recopy this, I'm just going to put log 10. So that becomes, all right, log x minus, now here I'm making this substitution, so so this would be log 10, all right, log, because that's 1, it's a secret base 10, and then plus log 6. All right, so that's the key to this whole problem, is making sure you do that. Now, the rest is pretty normal. If we do this step and combine these first. Now, as I go to combine these, this is a difference. So I'm going to use the quotient property. All right, where the difference of logs becomes the log of a quotient, you know, a fraction. And it's got to be x over 10. So I'm going to write, you know, log of x over 10. And that would be the same as this part. All right, for this moment, I'm just going to bring this part down. So plus log 6. Now, since this is addition now, that means we're going to be using the product rule. All right, so the sum of two logs will become the log of some product where you multiply. Okay, so I need to write a single log, and I'm going to be doing x over 10 times 6. So, I mean, look off to the side here. If I were to do x over 10 times 6, well, you know that's 6 over 1. So x times 6, that's just 6x. 10 times 1 is 10. All right, so that's what I would get if I multiply x over 10 times 6. I could also reduce it, though. Both of these are divisible by 2. So that would make 3x over 5. Okay, so that is what is about to happen right now. Okay, so let's see, how much of this do I really want to show? So maybe I'll show this one extra step. So if I put this as one log, what I have is x over 10 times 6 is what's happening with just the single log. But like I just showed you, if I do that, I get 3x over 5. So the final answer would be like this, log 3x over 5. And that is it. That is it both for this problem, and that is it for this particular lesson / assignment. All right, peace out, my friends. I will see you on the next video.